Um, Good morning, good evening, all. My name is Naresh. I am going to start one of the short videos on different cloud technologies and about the different data platforms like the data warehouse, data lake, dash lake house, and also the security of these different cloud providers, how the security works, and how the data governance works in this data lake house. Today I'm going to talk about the Snowflake in this video. So this is Snowflake is one of the leading cloud data warehouse in the market as of today. So let's get into the Snowflake. So what is the Snowflake? Snowflake uh, is a cloud data warehouse offered as a software as a service. Mm, That means software as a service means you don't need to maintain any infrastructure to run your Snowflake. So that's called the software as a service. Uh, to differentiate like all these clouds, right? AWS, Azure, and Google Cloud. We call them as a platform as a service. They give a platform to launch your infrastructure, deploy your application. The SaaS is at one level above that one. It's an abstraction on top of this clouds platform as a service. So that's about the SaaS of capability of the Snowflake. Uh, Snowflake is a SaaS solution. And what is so much what is the special about this Snowflake is it was built for the purpose of the cloud. It was not built for the to deploy it on the on-premise or hybrid mode. uh, what it means that it can run on the cloud and it can run on the major cloud providers Google, Azure, and AWS. And it is uh, Snowflake is not a data warehouse. It's more than that. That means we can call it as a complete data platform. So it not only allow you to do your data warehousing activities, it will allow you to do a different things like you can run uh, you can run the Spark jobs, they call the Snow Spark, and it will allow you to share the data without duplicating with with the clients. And the other is it will give you the uh, tools like the features like the snow pipe task streams to ingest your data. So this is one of the uh, uh, requirement for the data engineering. And also you can it's natively integrate with these data science tools like the Amazon SageMaker, Data Robot, so that means it integrates with these data science tools, AML tools. Along with that one, it is also a data lake. So what is the data lake? Data lake is allow you to scalable storage and compute. Like you can add in infinite storage and infinite scale. All you need to do is bring a new node so that it will brought the new storage and new capability to your existing cluster. And also it will Snowflake is allow not only allow you to store your structured data, but it allow you to store and process the semi-structured and unstructured data too. So that means If we have to tell this, if we have to say it's a data platform, complete data from is because it has the data warehousing capability, data lake capability, data engineering, data science, data sharing, and you can build applications using data application using the Java, Python, Scala, Spark, whatever your favorite language or the app framework. So, so to say that Snowflake is a data platform, not a data warehouse. And Snowflake is called the cloud native because it was built for the cloud. It was not built for the on-premise or a hybrid mode, and it was running on all the three cloud providers: AWS, GCP, Azure. Uh, I think these are the three major public cloud providers in the cloud. And since it is running on these all these cloud providers, so it will leverage the capabilities of all these clouds like the elasticity, scalability, high availability, cost efficiency, durability. So that is why the Snowflake is called as a cloud native. And as I said, right, is a software as a service. That means you don't need to maintain any hardware. The updates will come transparently to you. And you pay for it's a subscription based model. Like you pay for what you use, and it has a rich web UI. You can run your queries and do a lot of activities in Snowflake. So that's about software as a service. And coming to the architecture of the Snowflake is it's a multi-clustered shared data architecture. So what is that multi-cluster shared data architecture is? Before that, let's understand what is the different distributed architecture. So the different distributed are mainly there are two different distributed architectures. One is a shared disk architecture, one is a shared nothing architecture. Shared disk architecture, what it is mean? Like shared disk is like you will have one storage system, and these different compute systems will connect to that storage system. So that means you have only single source of truth data, and different compute systems share all this data. So, and the other architecture is the shared nothing architecture. In the shared nothing architecture is you have um, a different, you have all the machines, and each machine will have its own storage and compute. So those are the two different architectures: shared disk and shared nothing. So what are the advantages with the shared disk? So advantages with the shared disk architecture is it's simple to manage, and also there is only one copy of data, so that it's a single source of truth for your data. But the disadvantage with the shared disk architecture is that there is a single point of failure. Let's say if your storage server is gone, you are gone. You lose all your data. And also the other challenge is that storage system is always limited by the bandwidth and network latency and processing. Like it may not scale, it may scale to some extent, but it cannot scale infinitely. So that's another disadvantage with the shared disk architecture. So to address these some of these challenges, there is a the new architecture, other architecture was introduced, is a shared nothing architecture. In the shared nothing architecture, the advantage is like you have nodes, and each node brings some storage and capacity, and some latency issues. And these shared nothing architecture generally runs on commodity hardware, so that they are easy to build and maintain. And the advantage, another advantage is like if you wanted a more storage or more compute, you can simply bring a new node to that cluster, then your storage and compute getting increased or scale. But there are also challenges with this shared nothing architecture. So the other is like this. The one is like the storage is tightly coupled. So let's say you need a more storage, then you need to bring a machine that has the both storage and compute. That means you are paying for the compute, you don't use it. And there is a tendency to you over provision, and the resources get idle, so that you get paid for the resources you don't use it. So that's about distributed architecture. But what is the architecture Snowflake uses? The Snowflake uses a different architecture called it's a multi-clustered shared data architecture. So what is that multi-cluster shared data architecture is? In this one, you have in this architecture you have data storage layer that uh, uh, completely independent of your query processing or compute layer, where you can expand your data storage layers without increasing your query processing layer. Um, and there is that's about the like scalability with the data storage is infinite. And the other thing is you can scale your compute layer without increasing your storage layer, because these compute layers are different machines, different clusters, so they can be provisioned on the fly. Depends on the requirement. And also the compute layer, you will pay for what you use. Let's say you provision one compute layer and you use for 30 minutes, you get paid for 30 minutes. Mm. And then after that you can bring down the compute missions, so you don't get paid. And with this compute mission you get paid for at least 1 minute whenever you run a query. And then after 1 minute it's a per second basis. Let's say you run for the 10 minutes 15 seconds, then you will pay for 10 minutes 15 seconds, not for the 11 minutes. But if you run for 30 seconds, then you get uh, paid for 1 minute. So that means you are getting paid for what you use. Okay. And as I mentioned, and as we know, as I mentioned, like there is a separate storage and compute layer, then there is a separation of compute and storage management services. And this query processing layer, you can launch a different compute layer called the warehouses for your different workloads. That means you have a separation of the workload separations. You can use one warehouse for your data engineering, another ways for your BA users to query the data. So these are the two layers of the storage and compute, and there is another two layers also there. One is the cloud service layer. A layer, this layer is like a brain of your Snowflake. So where it will have a lot of other components, like it has an infrastructure management component, query optimizer. Whenever you submit your query is optimized, plan, build a logical physical plan, all these things will execute that query. Along with the transaction management, you can do that one. And data governance, apply the masking, encryption, tags, all those things, you can do that. Along with that, it will store the metadata for your data, like the database name, schema, stage, storage integration, table name, view, all those things. It will store that. And also it has an authentication and authorization modules, so it can natively integrate with your SSO. You can log in with your desktop credentials. or like you can have an authentication, Snowflake native authentication, that user ID password. So that's about multi-clustered shared data architecture of the Snowflake. And um, so um, that's a very quick introduction about the uh, Snowflake architecture. In the next videos, I'll go more into the uh, more details into the each layer and some of the capabilities of the Snowflake. Thank you.